Research Methodology. Chapter 2, Research Design. Part 2. Types of Sampling, Overview. I. Probability Sampling. 1. Simple random sampling. 2. Systematic random sampling. 3. Stratified random sampling. 4. Cluster sampling. 5. Sequential/multiphase sampling. 6. Sampling with probability proportional to size. 2. Non-probability sampling. 1. Convenience sampling. 2. Judgment sampling. 3. Quota sampling. 4. Snowball sampling. Probability sampling, Part A. 1. Simple random sampling. Every element in the population has an equal, known, non-zero chance of being selected. Uses random number tables or computer programs. Formula P equals sample size divided by population size. 2. Systematic random sampling. Every nth element is selected starting from a randomly chosen point. Skip interval equals population size divided by sample size. Simple and economical, but can miss hidden patterns in the data. 3. Stratified random sampling. Population is divided into subgroups called strata based on a shared characteristic. A random sample is drawn from each stratum. Can be proportionate or disproportionate. Probability sampling, Part B. 4. Cluster sampling. Population is divided into mutually exclusive clusters. A random sample of clusters is chosen and all members within selected clusters are studied. Offers heterogeneity within groups and homogeneity across groups. 5. Sequential/multiphase sampling, also called double sampling. A preliminary sample is studied first, then a subsample from it is selected for deeper investigation. Convenient and economical for multi-level studies. 6. Probability proportional to size, used when clusters have unequal numbers of elements. Probability of including each cluster is proportional to its size. The outcome is equivalent to that of a simple random sample. Non-probability sampling. 1. Convenience sampling. Information is collected from members who are easily available. Used in the exploratory phase of research. Quick and inexpensive, but results cannot be generalized to the full population. 2. Judgment sampling. Participants are selected based on the researcher's belief that they best meet the study's requirements. Suitable when only a limited category of people has the needed information. 3. Quota sampling. Participants are selected according to preset quotas based on demographics, age, gender, income, or behaviors. Ensures that specific subgroups are adequately represented in the study. 4. Snowball sampling, also called referral sampling. Initial respondents are chosen and then help identify more respondents. Used when the target population is very small, unique, and hard to reach. Sampling errors, biased and unbiased. A. Biased errors, errors that occur due to prejudice or bias on the part of the informant or enumerator in selecting, estimating, or using measuring instruments. These errors are cumulative in nature and increase as sample size increases. They arise due to defects in data collection, organization, and analysis methods. B. Unbiased errors, errors that occur accidentally in the normal course of investigation by chance, without any bias or prejudice. These arise due to faulty planning of statistical investigation. Unbiased errors can be removed with proper planning and care in using the correct measuring instruments. Non-sampling errors. Non-sampling errors arise due to factors other than the sampling process itself. 1. Data specification. Inadequate and inconsistent data specification leads to errors in what is collected. 2. Faulty methods. Faulty methods of interviews and observations introduce errors in data quality. 3. Lack of training. Lack of experience and proper training of investigators causes incorrect data collection. 4. Data processing. Errors made during data processing operations corrupt the final results. 5. Tabulation errors. Errors in the tabulation and classification of data lead to wrong conclusions. Meaning of research design. A research design is a master plan that specifies the methods and procedures for collecting and analyzing data in a research study. The word design means a plan or blueprint. A research design is therefore the blueprint of the entire research action. Research design involves decisions about the purpose of the study, its scope, location, type of investigation, and methods of data collection and analysis. It helps the researcher decide what, when, where, how much, and by what means to conduct the study. For example, a researcher studying customer satisfaction in banks will use a research design to decide what questions to ask, how many customers to survey, and how to analyze the collected data. Features of research design. 1. Objectivity. The design should use a measuring instrument where every independent observer gives the same score. This ensures the data collected is capable of analysis and drawing valid generalizations. 2. Reliability. Refers to consistency across a series of measurements. A respondent should give the same answer to the same item repeatedly. The researcher should frame questions to ensure consistent responses. 3. Validity. A measuring instrument is valid when it measures exactly what it is expected to measure. For example, an intelligence test should measure only intelligence and nothing else. 4. Generalizability refers to how well the data collected from the sample can be used to draw conclusions applicable to the larger population from which the sample was drawn. Characteristics of a good research design. A. Simplicity. Should be simple and easily understandable for all those involved in the research. B. Economical. The technique selected must be cost-effective and less time-consuming to implement. C. Reliability. Should yield the smallest experimental error with minimum bias and reliable data throughout. D. Workability. Must be pragmatic and practically executable under real research conditions. E. Flexibility. Must be flexible enough to allow consideration of different aspects of the phenomenon under study. F. Accuracy. Must lead to accurate and truthful results that can be trusted for decision-making. Nature of research design. 1. Blueprint of research serves as a detailed plan outlining how the entire study will be conducted, from problem formulation to data analysis. 2. Structured and systematic provides a logical, ordered sequence of steps, ensuring research is carried out in a scientific and organized manner. 3. Objective and unbiased reduces personal bias by specifying methods of data collection, sampling, and analysis in advance. 4. Problem-oriented, developed to address a specific research problem and guides the researcher toward achieving defined objectives. 5. Ensures reliability and validity. A well-planned design improves accuracy, consistency, and credibility of research findings. 6. Integrative approach combines methods of sampling, data collection tools, and analysis techniques into a unified research plan. Significance of research design. 1. Provides clear direction, acts as a roadmap for the entire study, guiding the researcher from problem identification through to conclusion. 2. Ensures systematic investigation, structures investigation in a logical sequence, preventing ad hoc decisions and making the study credible and replicable. 3. Minimizes bias, predetermining methods, sampling, and tools reduces personal bias, improving the scientific integrity of the study. 4. Enhances reliability and validity, ensures methods produce consistent and accurate results by eliminating errors and strengthening conclusions. 5. Efficient use of resources, ensures optimal use of time, money, and human resources by pre-planning all procedures and avoiding waste. 6. Facilitates proper data collection, specifies appropriate tools and sources to ensure data collected is relevant, accurate, and sufficient for analysis. Process of research design. Steps 1 to 5. Step 1. Selection and definition of a problem. The problem must be clearly defined in operational terms so the researcher knows exactly what facts to look for. Step 2. Sources of data. Clearly state the various sources of information, library, personal documents, fieldwork, or a specific residential group. Step 3. Nature of study. Choose at this stage whether the study will be statistical, experimental, or comparative, ensuring relevance to the problem. Step 4. Object of study. Clearly state whether the design aims at theoretical understanding or a welfare-based purpose to ensure clarity and sincere responses. Step 5. Social-cultural context. Set the design in its social-cultural context, clearly defining all terms to avoid large variation in interpretation. Process of research design, steps 6 to 9. Step 6. Temporal context. Refer to the geographical and time limits of the design, as research findings may apply only to specific social groups or periods. Step 7. Dimension. Select an adequate and representative sample, since analyzing data from a large entire universe is physically impossible. Step 8. Basis of selection. Follow proper mechanics for drawing random, stratified, purposive, double, cluster, or quota samples to produce valid, unbiased results. Step 9. Technique of data collection. Choose a suitable technique, observation, interview, or questionnaire. Once data is collected, analysis, coding, and report presentation naturally follow. Types of research design, overview. I. Exploratory research design. Used when the researcher does not know how or why a phenomenon occurs. Highly flexible and versatile. Used to identify problems and generate hypotheses. 2. Conclusive research design. Formal and structured, based on large representative samples. 2 subtypes. A. Descriptive research, longitudinal plus cross-sectional. B. Causal research, studies cause and effect relationships. 3. Experimental research design. Tests hypotheses for causal relationships. Reduces bias and allows valid inferences about causality. Based on replication and randomization principles. Exploratory research design. Exploratory research is conducted when the researcher does not know how or why a certain phenomenon occurs. It is used as the first step in the research process and is highly flexible and versatile in its design. Uses of exploratory research. 1. To define the problem more precisely and clearly. 2. To identify the most likely alternatives and relevant courses of action. 3. To isolate key variables and relationships for further examination. 4. To gain insights for developing an approach to the research problem. 5. To establish priorities for further research. Conclusive research design, descriptive. Descriptive research is undertaken to know the characteristics of certain groups, age, gender, income, etc. It answers the who, what, when, where, and how of the subject. More formal and structured than exploratory research. 2 types of descriptive research. 1. Longitudinal research relies on panel data. A fixed sample of subjects is measured repeatedly over an extended period. Allows the researcher to study changes and trends over time. Example: tracking market share changes year by year. 2. Cross-sectional research involves a sample selected at a single point in time. Most commonly used descriptive research design. Provides a snapshot of the population at one particular moment. Causal research design. Causal research design is the 3rd type of research design. It investigates the cause and effect relationship between 2 or more variables. It measures the extent of the relationship between the variables and attempts to specify the nature of the functional relationship that exists between them. Causal research is used to understand what causes what. It tests whether one variable truly influences or changes another. It measures both the degree and the direction of the relationship between variables. For example, a researcher may use causal research to study whether advertising spending directly causes an increase in product sales. Experimental research design. Experimental research tests hypotheses for causal relationships among variables. It requires procedures that reduce bias and lead to valid inferences about causality. 2 basic principles. 1. Principle of replication. Each treatment is applied to more than one experimental unit. This increases statistical accuracy and provides a more precise estimate of the mean effect of any factor in the experiment. 2. Principle of randomization provides the researcher protection against extraneous factors. Variations caused by extraneous factors are combined and termed as chance. Randomization is carried out using a random number table by A. Opening the table randomly, B. Selecting a column randomly, and C. Using the numbers in that column to determine the order of rows chosen. Thank you. Skill development questions in Chapter 5. Don't forget to subscribe to Riaz Notes. B.com BBA BCU. Riaz Notes.